Okay, here's your calendar. Pause it to be able to write it down because I'm about to click over to the other screen. All right, it's going on page 135 when we are done. We are still talking about vectors. Okay, so yesterday we looked at how to find a unit vector for a given vector that we may have. The standard unit vectors are I and j. They are positioned along the x and y axis, like so. So here's your x-axis, y-axis. So this is at 1, 0, this is at 0, 1. This is I, this is j. They go in alphabetical order just like x and y. So the vector for I, this unit vector, is 1, 0. And for j, it is 0, 1. So any vector, v, or that we call AB there, can be written in the form AI plus B times J. Okay. So that's just taking these two pieces, the x value times I, the y value times B. So this is called the linear combination of vectors I and j. So we follow the steps below to prove that these two things are equal. So the first thing we're going to do is take this right here, and we're going to rewrite it as the sum of two vectors. So V could equal A comma 0 plus 0 comma B. If I can write that correctly, 0 comma B. All right, so basically if I add those two back together, I get that. That works. Then I'm going to factor out A and B. So I get this is equal to, if I factor A out of that, I get A times 1, 0 plus B times 0, 1. Because if I multiply that back in, that would give me A, that would give me 0, give me the same thing. And then since 1, 0 is I and 0, 1 is j, then the vector is equal to A times I plus B times j. So we are going to rewrite each vector at first here as a linear combination of I and j. This should be very simple right here because this is just going to give us that V is equal to 2I plus 5j. That means that N is equal to negative 7I plus 3j. It's that easy. In order to be able to do these next ones, though, we have to come up with that component form first. So this vector RS, so RS is going to equal, I have to do negative 5 minus a negative 9, negative 6 minus 8. So my vector becomes, that's going to be plus a positive, so that'll be a positive 4, and then negative 14. That means that the vector RS as a linear combination is going to be 4 times I minus 14 times j. There's your answer. All right, so you pause the video and you do number 4. Then you pick it back up, but make sure you pause. All right, so in order for me to find this, vector PQ is first going to give me negative 2 minus a negative 10. 5 minus 6, so that's going to give me 8, negative 1. That means that the vector PQ is equal to 8I minus j. Okay. So let's talk about the trigonometric forms. If U is a unit vector, then the terminal point of U lies on the thing we love so much, the unit circle. Therefore, the vector U, which is AB, can be written as U equals, so if this is AB and we're on the unit circle, this is just like our XY on the unit circle, and the X for the unit circle was cosine theta, B was sine theta, so it looks like this. Cosine theta, sine theta. Or as a linear combination, U would be equal to cosine theta times I plus sine theta times j. Because every vector v is the product means we're multiplying, of its magnitude and its corresponding unit vector. So yesterday we didn't look at it this way. The way we had it written yesterday was that the unit vector is equal to 1 over the magnitude times the vector, right? But if I just multiply both sides by the magnitude, that's what I get here. So it's just a different form of what we did yesterday. So if the vector itself is equal to the magnitude times the unit vector, then the magnitude of v times cosine theta sine theta, or I could go ahead and multiply that in, and it could be the magnitude of v times the cosine of theta, and then the magnitude of v times the sine of theta, all in kind of inside there. Or as a linear combination of the magnitude of v times the cosine of theta times I plus the magnitude of v times the sine of theta times j. Okay, so there's a ton of definitions type stuff. Let's go look and see how we're going to use all this on the back. All right, so number 5. We have the magnitude is 8, theta is 60. It says find the component form. So component form, remember, is this one. Find the component form of each vector with the given magnitude and direction angle. So remember that the vector be equal to cosine theta, or I'm sorry, it's not just cosine theta, sine theta, because these aren't unit vectors. Instead, it is the magnitude of v times the cosine of theta, and then the magnitude of v times the sine theta. It's kind of like r cosine theta, r sine theta that we did before. So the vector is equal to 8 times the cosine of 60, 8 times the sine of 60. All right, so the cosine of 60 degrees without your calculator, 60 is pi thirds, so the cosine is 1/2. So this is equal to 8 times 1/2. And then the sine of 60 is the square root of 3 over 2. So this will be 8 times square root of 3 over 2. When you simplify that, you're going to get that, that the vector is equal to 4 square root of 3. Okay. All right, let's look at number 6. W is going to be equal to 20 times the cosine of 225, and then 20 times the sine of 225. That's a special angle also, but we didn't spend a lot of time with them in degrees because it's not necessary. You can go ahead and type all that in your calculator, just like it is. And then that means in the end what you should get. Now, you can't type it in all at once because it's not an equation. Like, you're going to have to type this one and then type that one because of the comma. Don't try and be weird in the calculator. This is equal to negative 10 square root of 2 and negative 10 square root of 2. No, absolutely do not want decimals unless you have to have decimals. Okay? Don't have to have decimals if it gives you the good square roots. Okay, so then you pause the video and you do number 8, or 7 and 8. Once you're done with that, then unpause it. See if we agree on what we're doing, on what to do. So I'm going to do for k, this is going to be equal to 12 times the cosine of 150, 12 times the sine of 150. So once I type all that in, I get that k is equal to negative 6 square root of 3, 6. Okay, then a is equal to 30 times the cosine of 340 and 30 times the sine of 340. That means a is equal to 28.191. So this one I have to have decimals because it wasn't giving me anything exact, comma, negative 10.261. There we go. And you should be able to check your quadrants here. 225 is more than 180, less than 270. So that's quadrant 3, and this is a quadrant 3 vector. This is 60, that's quadrant 1, that's in quadrant 1. This is 150, that's quadrant 2, quadrant 2. Quadrant 4, quadrant 4. So we need to pay attention to our quadrants here. If we want to write each one of these in trigonometric form, let's think about our quadrants. 15, 8, that would be quadrant 1. So I should be good with kind of anything that comes out of there. I need in order to do this, I need the magnitude and I need the angle. So first I'm going to find the magnitude. Magnitude of V is going to be equal to the square root of 15 squared plus 8 squared. Okay. That's going to give me the square root of 289, which is a perfect square of 17. Then I also need the angle. So if you think about what we did a couple days ago when we were looking for these angles, this is how we found the magnitude. It was just the square root of a squared plus b squared. But the angle, tangent theta, is equal to b over a. So this is 8 over 15. So I take the tangent inverse, and theta is equal to 28.072 degrees. Right. So then my vector is going to be equal to 17 times the cosine of 28.072 degrees, and then 17 times the sine of 28.072 degrees. We could have written it with 17 out in front, like a scalar, but I think it makes more sense this way. All right? So you pause and try number 10. All right, so I'm going to have the magnitude of m. That's equal to the square root of negative 3 square root of 2 squared plus negative square root of 6 squared. Now, chances pretty good that somebody messed up by typing all this stuff in the calculator and didn't type it all in correctly. So you got to make sure that you can make sense of this without a calculator. When I square this here, this is going to give me 9 times 2. This is 18. Plus the square root of 6 squared is just 6. That means I end up with the square root of 24, which is 2 times the square root of 6. And I know the calculator will simplify the square root for you, but you may not have gotten there if that didn't make any sense. Make sure you can also do it without the calculator. All right, so then I need to find theta. So the tangent of theta is equal to negative square root of 6 over negative 3 square root of 2. That is going to give me, well, actually, it doesn't even matter. If you're going to do the inverse in the calculator, you can do you don't necessarily have to rationalize and stuff, but you also want to be careful when you're doing that, that you're going to do things correctly, meaning that you're using your parentheses correct and all that good kind of stuff. This does simplify down pretty easily, but since it's not our final answer, I would just say that when you type it in, those two negatives make a positive. I wouldn't try and make any kind of negative mistake there. But you could put in the square root of 6 over 3 square root of 2, especially if you're using the calculators that we have in class, because I would actually put it in a fraction so it looks exactly like that. Either that or rationalize so that you don't get anything weird, because that actually rationalizes out to the square root of 3 over 3. And we should also know what the tangent inverse of that is, but you probably know it in radians and not in degrees. But either way, just be very careful when you're using things like that. So now that we have when we get the angle, so you would get that theta is equal to 210 degrees. So we have theta, we have our magnitude, so that means that the vector is equal to the magnitude, which is 2 square root of 6 times the cosine of 210, and then 2 square root of 6 times the sine of 210. There's your answer. All right, let's do 11 together. So to do 11, oh, we weren't paying attention to our quadrants here, so let's double check on this. We have a, oh, when you do the tangent inverse of that, dang it, when you take the tangent inverse on your calculator, you're actually going to get 30. But this is negative, negative, so we're in quadrant 3. So remember, when you get a quadrant 1 angle, but you want a quadrant 3 angle, you add 180. So if I take that 30 plus 180, that's where that 210 comes from. Sorry. All right, so let's look at number 11. Let's go ahead and look at the quadrant first so that we don't forget about it. This is I and j. This is your x and your y. So it's negative x, positive y. We're in quadrant 2. I can write this in the component form, if maybe that makes a little bit more sense. That'd be a negative 1, 7. So then we substitute that in. We're going to get the magnitude of p. It's going to be equal to the square root of negative 1 squared plus 7 squared. It's going to be the square root of 50, which is 5 square root of 2. So there is my magnitude. Then I need to find my angle. So I'm going to take the tangent, or the tangent of theta is equal to 7 over negative 1. So theta is the inverse of, is the tangent inverse of negative 7. So when you do that, you get that theta is equal to a negative 81, blah, blah, blah. But remember, this is a quadrant 4 angle. If I have a quadrant 4 angle and I want a quadrant 2 angle, I'm going to add 180. And when you add 180, you actually get that theta is equal to 98.130 degrees. So that your vector is equal to the magnitude, which is 5 square root of 2, times the cosine of 98.130 degrees, and then 5 square root of 2 times the sine of 98.130 degrees. All right, so pause this, do number 12, then unpause it and see if we agree. All right, so negative 2, 2 is going to be in quadrant 2 again. My component form looks like this. So the magnitude of r is equal to the square root of negative 2 squared plus 2 squared. So that's going to be 4 plus 4, that's the square root of 8. Can't even write an 8. Oh my goodness. 8, there we go, which is 2 square root of 2. All right, so there's my magnitude. Tangent theta is going to be equal to 2 over a negative 2, which is negative 1. So I'm going to take the tangent inverse of a negative 1. When you do that, you're going to get negative 45, but that is a 4th quadrant angle. We want a 2nd quadrant angle, so we add 180 to that, and theta is equal to 135 degrees. And there are my two pieces. So my vector is 2 square root of 2 times the cosine of 135, and 2 square root of 2 times the sine of 135. And there you go. All right, number 13. Here's my vector AB, with this being A and this being B. Remember, the order does matter here. This has to be x1, y1. This has to be x2, y2. So before I do anything, I have to find my vector. So that's going to be equal to negative 9 minus a negative 1, and 3 minus 7. So that's going to be negative 9 plus 1, so that's negative 8. 3 minus 7 is negative 4. So now that I have that, find the magnitude. That's going to be equal to the square root of negative 8 squared plus negative 4 squared. That's going to be the square root of 80, which is 4 square root of 5. There's my magnitude. Tangent theta is equal to, looking at this right here, it's going to be negative 4 over negative 8, which is 1/2. So I'm going to take the tangent inverse of 1/2. That's going to give me 26 something, but we didn't look at our quadrant. This negative 8 and negative 4, that's quadrant 3. When you get your 26, degrees, whatever, out of the calculator for this, then that's in quadrant 1. We want quadrant 3, so we add 180. That's what I was about to write. We add 180, and when you add 180, you get to 206.565 degrees, which means my vector is equal to 4 square root of 5 times the cosine of 206.565 degrees, and then 4 square root of 5 times the sine of 206.565 degrees. Okay, and there you go. All right, now you pause the video, you do 14, and then come back and see if we agree. All right, so for me to do this, okay, this is my x1, y1, x2, y2. So the vector is 5 minus 3, negative 8 minus a negative 2, which gives me 2 and negative 6. Okay, so there's my component form. 2, negative 6, that is quadrant 4. All right, so then my magnitude of this vector is equal to the square root of 2 squared plus negative 6 squared. It's going to be the square root of 40, just 2 square root of 10. There's my magnitude. Tangent of theta is equal to negative 6 over 2, which is negative 3. When you find the tangent inverse of negative 3 in your calculator, you're going to get a negative angle, negative 71 something. Okay, well, a negative 71 something is in the 4th quadrant. I want a 4th quadrant angle, but I want it positive, which means I have to add a whole 360. Once you add 360 to that, you get 288.435 degrees, which means your vector, yz, is 2 square root of 10 times the cosine of 288.435 degrees, and 2 square root of 10 times the sine of 288.435 degrees. And there is that vector. Okay. You already have the assignment. It's the back of what I gave you yesterday. You should be able to go forth and complete the rest of these vectors.